Let us take a look at how to find the domain and range of rational functions. We're going to first look at how to identify rational functions. We're going to review the inverse of functions, and we're going to then identify the range and the domain of rational functions. So a rational function is a function that represents a rational fraction. And a rational function has a function in the numerator and the denominator, and we always have that the denominator cannot be equal to 0. Now let's look at a few examples of this. We have 1 over x plus 1. In a rational function, the numerator can be just a whole number, but the denominator must be a function. So you can see here we have, for this first one, f of x equal to 1 over x plus 1, we have the denominator is a linear function. In this second case here, we have 3x over 2x plus 1. Numerator and denominator are linear functions, and then we have f of x equal to 3x squared minus 1 over 2 over x minus 2. We have a quadratic in the numerator and a linear in the denominator. We could also have this flipped around such that we have a linear in the numerator and a quadratic in the denominator. Now we're going to look at the inverse of a number. What we're going to do is, it's important to know how to find the inverse of a number, and we'll see that shortly. So we're going to write the function as y equal to f of x, exchange the x and y variables in the function, solve for y, and then replace y with the f inverse of x. There is a video that covers this extensively, but for the sake of this topic, we're going to just go through one example. So we're saying we have y equal to 3x over 2x minus 1. Now we're going to replace the y with the x and the x with the y. So we have x equal to 3y over 2y minus 1. Now we're going to solve for y. So we're going to do a cross product here. So this multiplies by this and this multiplies by this. So 3y is equal to x multiplied by 2y minus 1, which is 3y equal to 2xy minus x. We're going to group all the variables with y together. So we have 3y minus 2xy equal to x. Now what we're going to do is we're going to figure out a way to get y to stand on its own. So that will happen by factoring the left hand side. So we have y into 3 minus 2x equal to x. Actually, this should be negative x. So that's negative x. You divide both sides by 3 minus 2x. 3 minus 2x. So we have y equal to negative x over 3 minus 2x. So we're going to replace the y with f inverse of x equal to negative x over 3 minus 2x. Now, how do we find the domain of a rational function? We want to solve the denominator of the function by equating it to 0 to find the real roots of the denominator. These will help us identify the domain restrictions. What that means is we're going to find the values for which the domain will be undefined, for which the function will be undefined. the domain will exclude the results from step 1, and then we're going to write the domain as an interval. Let's look at a few examples here. So what is the domain of the function f of x equal to 2x equal to x minus 1 over 2x minus 3? So what we're going to have here is that let's try 2x minus 3 equal to 0. So we add 3 to both sides until we have 2x equal to 3. Divide by 2. So x equal to 3 over 2. So what we're going to see here is that this is going to be the restriction. So what we're going to see here with this function is that your domain is going to be minus infinity all the way to 3 over 2, and then we're going to have a union. Then we have 3 over 2 infinity. So let me show you that on the number line. So what we're saying here is that we have, right here is 3 over 2. So we're going to have an open circle here. So all the values to this side are valid, and all the values to this side are valid. So we do not have 3 over 2 as a valid point on the domain. Now, what is the domain of the function of f of x if 2x plus 3 over, if f of x equal to 2x plus 3 over x squared minus 6x minus 16? So we're going to first look for the zeros. So x squared minus 6x minus 16 equal to 0. Let's factor x squared minus 6x plus 16. You can either use the quadratic formula, or you can see if you can factor this. Let me try this using the discriminant to give me an idea of if it's going to be easy to factor. So b squared minus 4ac, let's see what that is going to be. This is going to be minus 6 squared minus 4 times 1 times minus 16. So this is going to give me 36 plus 64, which is 100. Okay, so this should be easy to factor. So we're going to have, let's see, we have negative 16, and we need to find the factors of negative 16 that add up to negative 6. So negative 16, we have 8 and 2. There's a relationship there. So now we have x minus 8, x plus 2 equal to 0. X minus 8 equal to 0. We have x equal to 8. X plus 2 equal to 0. We have x equal to negative 2. And so let's put out our number line. We have negative 2, and then we have 8. So we're going to have all the values here from negative infinity to negative 2. We're going to have an asymptote here, which is this will not be a valid point. This also, 8 will not be a valid point. And then we have every value after 8. So our domain is going to be from negative infinity to negative 2. We're also going to have negative 2 all the way to 8. And then we're going to have 8 to positive infinity. So to join them together, we're going to put the union sign right here. Finally, what is the domain of the function f of x equal to x squared 7 over x squared plus 1? So we're going to try to equate the denominator to 0. X squared plus 1 equal to 0. X squared equal to negative 1. So x equal to plus or minus square root of negative 1. This will not give us any real values, so we have no real values. So what that means, because we have no real values, that means every number from negative infinity to positive infinity will be valid because we do not have any restrictions. So we're going to have negative infinity all the way to positive infinity. So we look at the range of a rational function. First, to find the range of a rational function, we'll find the inverse of the rational function, and then we'll find the domain of the inverse of this function and write the domain as an interval. One of the reasons why we do it this way is with the understanding that when you're dealing with inverse of a function, so the domain of a rational function is also the same as the range of its inverse. And the domain of an inverse function is the same as the range of the original function. So let's look at some examples here. So we're going to look for the inverse of the function f of x equal to x minus 1 over 2x minus 3. So let's start with y equal to x minus 1 over 2x minus 3. So x equal to y minus 1 over 2y minus 3. We're going to cross product here. So we have x multiplied by 2y minus 3 equal to 1y minus 1. 2xy minus 3x equal to y minus 1. So we have 2xy minus y equal to 3x minus 1. Y 2x minus 1 equal to 3x minus 1. Divide both sides by 2x minus 1 minus 1. So we have y equal to 3x minus 1 over 2x minus 1. So therefore f inverse of x equal to 3x minus 1 over 2x minus 1. And the domain here, the domain of f inverse of x, we're going to do that by solving the denominator. 2x minus 1 is 0. 2x equal to 1. Divide both sides by 2. So x equal to 1/2. So the range of f of x is going to be negative infinity all the way to 1/2 union 1/2 all the way to infinity. Another example, we're going to first find the inverse of this function. Y equal to 2x plus 3 over x minus 6. X equal to 2y plus 3 over y minus 6. So we have x multiplied by y minus 6 equal to 2y plus 3. You have x, y minus 6x equal to 2y plus 3. We group all the y's together. xy minus 2y equal to 6x plus 3. Y x minus 2 equal to 6x plus 3. Divide both sides by x minus 2. X minus 2. So we have y equal to 6x plus 3 over x minus 2. Therefore, f inverse of x equal to 6x plus 3 over x minus 2. So we solve for the domain of f inverse of x, we solve for the denominator. So this is going to be colon right here, x minus 2 equal to 0, x equal to 2. So now the range of f of x equal to negative infinity all the way to 2, union 2 all the way to infinity. What is the range of the function f of x equal to 7 over x squared plus 1? We start y equal to 7 over x squared plus 1. We now replace x equal to 7 over y squared plus 1. We have a cross product, so x multiplied by y squared plus 1 equal to 7 multiplied by 1. So we have xy squared plus x equal to 7. We're going to isolate any variable with y on the left hand side. So we have xy squared equal to 7 minus x. We divide both sides by x. And then we have y squared equal to 7 minus x over x. Now we're going to take a square root of both sides. So square root plus minus. So y equal to square root of 7 minus x over x. So now we need to find so first we write this as f inverse of x equal to the square root of 7 minus x over x. Now we need to find the domain of this function. We have to take two things into consideration. One, we cannot have x cannot be equal to 0 because then your square root is going to be undefined, so we can't have x equal to 0. The other thing is we cannot have 7 minus x over x must be greater than 0 because we cannot have negative square roots. So we cannot have a negative number under the square root sign. So now we're going to solve this to make sure that 7 minus x over x must be greater than 0. So what we're going to have here is we're going to multiply both sides by x. Multiply by x, so 7 minus x is greater than 0. Minus x is greater than minus 7. Then we divide both sides by negative 1. So we have x is less than 7. So now we have a situation where x cannot be equal to 0 and x must be less than 7. So let's look at it right here. We have two holes. X cannot be equal to 0. This is 0. And we have x must be less than 7. So based on this, one of the things we're going to see here is if we have a negative value for x here, we're going to make this function under the square root sign negative. So what we're going to end up with is we're going to have only numbers between 0 and 7. So we're going to have a situation where we have 0, 7. That's going to be the domain of the inverse function. So the range of f of x equal to 0, to 7. So they should have a greater than equal to right here. You can have 0. So it's going to be less than equal to. So we have 7 is going to be an included point in this range. So these are the major things you need to know about the domain and the range of rational functions. When we're looking at radical functions, we'll look at that in a separate video.